Hey everybody, it's Cal here from Wise Guys Tutoring. We're going to continue our EmSAT Math sample paper from 2020. Today we're going to be doing questions 11 to 15. So as usual, we're not just going to solve the questions, we're actually going to talk to you about the topics of each one. So let's get started with question number 11. So question 11 says select all true statements, and all the statements have to do with rational, irrational numbers. So I'm going to take it just one step further, and we might as well talk about all the number types, okay? So the first one we know of or learn about usually are natural numbers. Natural numbers are just the integers on the positive side. So they go 1, 2, 3, 4, 5 all the way to infinity. There's something closely related which is called whole numbers, and whole numbers is the same thing, but they include 0. Let me just tell you something. Some people consider natural numbers to include 0. You know, whole numbers is not a very official thing, but anyway, in case they come up in a separate context, then you know the difference is whole numbers includes 0. The next one is integers, and integers include even negative numbers. You know, I should start it with a ellipses there because they can include, goes from minus infinity all the way to 0, and then 1, 2, 3, and all the way to infinity. Okay, those are called integers. They are whole numbers. They can be negative or positive, and they include 0 as well. So now let's talk about what they're talking about, which is rational numbers. Now, rational number is any number that can be written as a fraction. What that means is, if I can write it as a fraction, it is a rational number. For example, regular fractions that we know of, like 1 over 2 or 3 over 5. These are rational numbers. But also, look at these whole numbers. For example, couldn't I write 3 as 3 over 1? Since I'm able to do that, that means that whole numbers are included. All integers, in fact. Minus 12 over 3, this is equal to negative 4, right? So all of natural whole numbers and integers are in fact types of rational numbers, okay? As long as you can write it as a fraction, it is a rational number. There is a misconception that people think that rational numbers are you know, finite numbers. That means they don't go on forever. But that's not true, right? Because 1 over 3, if you put that in your calculator, you'll know that it has a recurring 3 that goes on forever, right? Or 4 over 9. This is equal to 0.4 recurring. Now, if you have a recurring number, that's okay. You are still considered rational, because if you have a recurring number, you can be written as a fraction, okay? What we have to watch out for are irrational numbers, and let's talk about the difference with those. Irrational numbers are numbers that go on forever, and they are non-repeating, okay? Non-repeating and infinite, okay? They cannot, this is the important part, they cannot be written as a fraction. So what you'll see here are numbers like pi, and when you have square roots of numbers which are not perfect square, these are numbers that go on forever and they cannot be written as a fraction. So these are called irrational numbers, okay? Now let's try to solve some of these. Which statements are true? Since 13.1 is a terminating decimal, it is rational. So whenever you have a terminating decimal, that means it is very easily rewritten as a fraction. For example, 13.1 can be 131 divided by 10. Okay? So since I can write it as a fraction, all terminating decimal numbers are rational. So that one's good. We'll keep it. Since 14 over 4 is a ratio of 2 integers, it is rational. Yes, that is the definition of a rational number. It can be rewritten as a fraction. There you go. C says, since 7 is not a perfect square, the square root of 7 is rational. Well, we kind of just saw over here in the purple that square roots of non-perfect squares are actually irrational. So that's a never-ending, non-recurring number. Can't write it as a fraction. It is not rational. Since 16 is a perfect square, square root of 16 is irrational. Well, square root of 16 is simply equal to 4. And as we know, we can always write 4 as, for example, 4 over 1. We can rewrite it as a fraction. So it's actually a rational number, not irrational. So that one's no good. E It says since 5.84 recurring, that's what that bar means. It means this number is actually 5.848484 forever, is a repeating decimal, it is rational. Now this is true. If you look at the, the solution sheet of this sample paper, it'll actually tell you that this is not part of the answers, but that's not correct. This one is good. And I can show you that 5.84 recurring can be rewritten as 579 divided by 99. And if you don't believe me, pop it into your calculator. Since it can be rewritten as a fraction, what do we say? We say this is definitely a rational number. So this is actually good. The answer should in fact be A, B, and E, even though it's excluded from your answers. Okay, let's do number 12. Number 12 says, what is the period of the graph of the function below? So before we do that, we got to kind of talk about the graphs of sinusoidal functions. So they kind of look like this. I'll do my best to do it, but I'm doing it freehand. Freehand, people. It looks like this, goes down. It's like a wave, okay? And it goes on forever, so I'll just do a little dash here, where this is X and this is Y. Okay, now the original gangster OG format, this is sine X. This is called Y equals sine X. That's this function. Okay, and let's talk about what some of these points are. So first of all, it starts at 0, and this point here is of interest to us. Maybe I'll use light blue so we can tell the difference. This point here would be pi over 2. The coordinate of this one, it's an x is pi. You have this point here, which is the peak. This happens at 3 pi over 2. And this here is 2 pi. Okay? The height, if you will, over here is 1. And the minimum height is -1. And I guess you can kind of tell that the center line is 0, right? The x-axis, that's the center line. So we can talk about a couple of things, okay? What this thing is called, the height between the center line and the maximum point, or whatever you want, you can use the center line to the minimum point. They are the same height. This is called the amplitude. The amplitude of this sine wave, or of the sine function. That's the amplitude. Okay, another thing we need to consider is this part here, which is called the period. The period. Now, how did I find that? The way you do that is basically we need to take one copy paste unit of this wave. As you know, the wave goes on forever. If I were to draw a mini one here, it would just keep going on forever and ever and ever. And if you're trying to find one cycle, as we call it, you're basically trying to take one copy paste unit that repeats itself over and over again. Okay, so for us right now, the period here, the period is 2 pi. Okay, so we got the center line. Center line is y equal to 0, which is the x-axis. The period is 2 pi, and the amplitude is 1. Okay, that's the original y equals sine x function. Now let me give you the full version, the general version, let me call it. It's y equals a sine of b times x minus c plus d. Okay, now it looks kind of crazy, but it's not that bad, and I'll show you why. First of all, a will be the amplitude. This is called the amplitude, which we saw is the maximum and minimum deviations from the center line, how high up or how low it goes from the center line. And the center line that we're talking about is this guy here. This number is the center line. The center line of my sinusoidal function is going to be y equals this number. In fact, it's basically just a vertical shift, right? What I mean is, let's say d was 5. well then my graph, instead of being centered at y equals 0 at the x-axis, it would look a little bit like this. It would look like 5, and you'd have your wave going up and down around this center line. Okay, so it's a vertical shift. It's like I took the original guy and I shifted him up. So if D is positive, it's a shift up. And if D is negative, you get a shift down. Okay, makes sense? So let's move on now to B. B over here will tell me about the period. The period is always going to be 2 pi divided by this number, whatever it is. Okay, the period is always 2 pi divided by B. And lastly, we have C. And C is sort of like D. This is called the phase shift. Phase shift. And it's basically a horizontal shift. When I say shift, by the way, that means sliding. You know, the D will slide your whole graph the same way it looks like. It'll just slide it up or down. C will slide it left and right. And C is a bit reversed because if C is negative, you shift to the right. And if C is positive, that means shift to the left. Okay? I should probably get rid of these arrows in case they're confusing. There you go. So that's what the whole format would tell me. So now let's look at this one. It says y equals minus 2 over 3 sine of 3 over 2x. So from this, I can tell you that, for example, D and C are non-existent. That means my center line is y equals 0, is the x-axis like usual. I can also tell you that the amplitude is minus 2 over 3. Well, we take the absolute value of that. It'll be 2 over 3. And the most important thing that they want is the period. And how do we find the period? Well, I do 2 pi divided by b. B being the coefficient of x, the multiplier of x. So let's calculate that. My period will be 2 pi divided by 3 over 2. And hopefully you know how to divide fractions. It's just a multiplication of the inverse. So here it is. That's how you divide. And when you multiply, it's even easier. You do the top with the top. So that gives me 4 pi. And bottom with bottom, which is 1 when you don't see a denominator. It's like dividing by 1. 1 over 3. There you are. So the period of this function that they've given us is 4 pi over 3. That means the answer is A, but they've made a small typo. It should be 4 pi over 3, not 4 over 3 pi. Okay, let's move on to the next question. So 13 says, which graph represents the function y equals minus cotan parentheses pi x over 2? So to do that, we need a bit of basic knowledge of the unit circle, which I've drawn here. We've talked about the unit circle earlier. If not, you should check out the first video, the questions 1 to 5 again. So just to give you a quick reminder, this is what's going on. The unit circle is a circle whose radius is equal to 1. And it's plotted against axes where the x-axis is basically cosine of the angle x, and the y coordinate will be sine of that angle x. Okay, so for example, if my angle was pi over 6 radians, then the coordinate of this point over here, the x coordinate would be root 3 over 2, and the y coordinate would be 1 over 2, because this is sine of pi over 6, and this one is cos of pi over 6. You can put that in your calculator, you'll get these values. That means the coordinates of this point are root 3 over 2 and 1/2. Okay? So why do I tell you this? Because we need to realize that there are certain points here that are sort of, unique on the circle. This point here, when the angle is 0, has a x coordinate of 1 and a y coordinate of 0. The point over here has a x coordinate of 0 and a y coordinate of 1. So, sine of x is 1 and cos of x is 0. This point here similarly has cosine is -1, and sine of this angle is 0. And lastly here at 270 degrees, we have 0 and -1, right? Remember, this is just the x coordinate, which is cosine of the angle. And this one here is sine of the angle, whatever the angle is. So now let's talk about tan, okay? So hopefully you remember some trigonometry. Let me change colors, maybe some purple. We remember this, okay? Tan of anything, of an angle, is equal to sine of that angle over cos of that angle, okay? So we're going to apply the same theory here, and we're going to say that tan of pi x over 2, well, this is just going to be equal to sine of pi x over 2 over cos of pi x over 2, okay? And I'm going to take it one step further and say that cotan of this, well, cotangent is the inverse of tan, so I literally just flip these guys over, so it becomes cos of pi x over 2 over sine of pi x over 2, okay? Now, if you'll notice, let's get back to the graph. If you'll notice the graph, it has a lot of vertical asymptotes, and it has a lot of cycles, right? The reason being, just like we saw just a bit earlier about the sinusoidal waves being, you know, a continuous, never-ending wave going up and down, it's cyclical, and so is tan. That's why you have an infinite number of these squigglies, if you will. That's not a technical term, don't quote me on that. But basically it's cyclical, okay? So it never ends. The second thing you notice is these, what do you call them? Vertical asymptotes, okay? And where do they come from? They come from this denominator. When the denominator is equal to 0. See, in math, there is a cardinal rule where we are never, ever allowed to divide by 0. And even if you check it on your calculator, you put 2 divided by 0, it's gonna yell at you. It's gonna say math error, and it might even explode. Just kidding. But you can never divide by 0. And if ever your denominator is equal to 0, well, this function cannot exist. And that's why you have these asymptotes. They are values of x, which make my function not defined, undefined. So let's talk about this denominator here. When is sine pi x over 2? When is this going to equal 0? It's going to equal 0 when my angle is equal to 0, or when my angle is equal to pi. That means this part here, when this one is equal to 0, and when this one is equal to pi. So now we can use these and solve for values of x that make, you know, this part equal 0 or pi, which makes my whole denominator equal 0, which makes my whole function not exist, and then we'll be able to figure out which one of these is correct. So check it out. To solve these algebraically, and if you're not sure how to do this, then you should check out our algebra solving videos. So first we multiply both sides by 2. You're left with pi x equals to 0, because 0 times 2 is simply 0. And then if you divide by pi on both sides in order to get x all alone, then you'll notice that one of the solutions is x equals 0. That means I should have a vertical asymptote at x equals 0. Let's see what this guy tells me. I'll multiply both sides by 2 in order to get rid of this guy. I'll get pi x equals 2 pi. And then I'll divide by pi on both sides. There you go. And what I'm left with is x equals, these ones also cancel. You get x equals 2. So that means that x equals 2, this function is also undefined. So which one of these graphs has asymptotes at 0 and 2? Well, it seems only this one does. And that will be our correct answer. Let me show you guys what the graph looks like for tan anyway, and maybe that's another way that you can figure out this question. So tan is sine over cosine. So when cosine is 0, it does not exist, and cosine is 0 at pi over 2 and at 3 pi over 2. So you get, you know, this is pi over 2, then you'll get a asymptote there, and you'll get one when you have 3 pi over 2 again. Okay, so you get asymptotes like that. And we also can know that the cycle is 2 pi, right? So it looks a bit like this. And when the angle is 0, then it's 0 divided by 1, which gives me a value of 0. So the tan function ends up looking like this. Squigglies that pass by like this. It's also 0 here when it's pi and such. So that's what tan looks like, tan of an angle. Now cotan, let me show you what cotan looks like. So cotan will be 0 at pi over 2 and will be have asymptotes at pi, right? Because it's being divided by sine, and when sine is 0, that can't happen. So cotan looks more like this, and it's these red squigglies like that. So if that's what you get for cotan, then when you do minus cotan, I know it's getting messy, so I'll do a new graph over here. So when you do minus cotan, you get the same thing, but it's inverted, so it looks a bit like this. So just by the shape, you know, I can also confirm that A is good. All right, so that was a pretty tough question. Hopefully you were able to follow, and let's move on. All right, so question 14 says, what is the sum of square root of 27 and square root of 108? We've talked about this, about simplifying surds and such. First thing you need to do is you need to know your squares. I'll put 1 even though it's not very useful. So 1 squared, 2 squared, that's 3 squared, that's 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. Up to 100 is okay, I think. You can manage with those usually. So square root of 27. So this is what we're going to do. Here's the first one. What you need to do is you need to simplify them. Simplifying surds. So here's the first step. You got to rewrite this as a product of two numbers, one of which is a perfect square from this list over here, this long list I took so long to make. So for example, what is the biggest square that's a factor of 27? I would say it is 9. So 27, I'm going to rewrite it as 9 times 3. Okay? So till now I haven't done anything illegal or anything. I've just rewritten 27 as 9 times 3. Now here's a rule regarding roots, okay? You can split this up. So this is root 9 times root 3. And root 9, because it's a perfect square, right? We were very clever and we chose one purposely from this list. This is just 3. So you get 3 root 3. That's what root 27 is simplified to. Okay? So let's do the same thing. Why don't I use the other side? Let's say we're doing root 108. So again, I try to split it up as a product of two numbers, and I use the biggest square, perfect square I can find. So for 108, that would be 36. 36 times 3. Again, I do the same thing, so you're allowed to split them up. So that's root 36 times root 3. And because we chose a perfect square, square root of 36 is simply 6. So now I have them simplified, right? Now it becomes really, really easy, because if they say, what is the sum? And they're asking me, what's 27 plus square root of 108? Well, I can rewrite it in my nice simplified way. I can say this is just 3 root 3 plus 6 root 3. And whenever you're adding 3 of something to 6 of something, it always gives you 9 of something. Okay? I don't care what's inside, right? This could have been 3x plus 6x. It would give me 9x, right? Or if I have 3 hearts plus 6 hearts, it would give me 9 hearts. Oh, that one did not turn out well. But anyway, whatever it is, if you have 3 of something and you have 6 of something and you add them up, you get 9 of something. So there you go. This is a simplified version. When you add them up, 9 root 3a. Let's do question 15. This one says, select all relations that are a function. So we need to define functions. Mathematically speaking, what is a function? So I'm going to give you the layman's terms, okay? Basically, a function is one y value for each and any x value. What do I mean by that? That means two x values, let's say, can have the same y value. That's okay. I'll give you an example. If we're talking about a parabola or something, then this value of x, which is 2, has a y value of 4, and a x value of -2 will also give me a y value of 4. So they are two x values and they have the same y value. That's totally fine. That's not a problem. That means that y equals x squared here. This is a function. What is not fine, what is not cool, is x value cannot have more than one y value. One only. Okay? So an x value can never have more than one y value. Let me give you an example. Let's do this parabola, but let's do it sideways like this. Okay? Is this one a function? Let's see. This value of x, let's say it's 2, has two values of y. It has 4 and it has -4. That is not good. This one is not a function. Not a function. Okay? Because you just have to say, does an x value have more than one y value? If any x value has more than one value, it is not considered a function. Okay? So now let's check out the answers that we have here. Let's look at A. A shows me a bunch of coordinates. Remember, the first one is x and the second one is y. So what we have here is when x is 9, y is 5. That's fine. Now when x is 2, y equals 5. And when x is 5, y equals 5. So basically this is kind of fitting this first scenario where multiple values of x have the same value of y. That's fine. Not a problem. You know, instead of 2, I should probably write multiple, right? So multiple x values can have the same y value. That's fine. Let's look at the second one. Domain refers to, you know, range of x, and range refers to the interval in y. So these are like the x values and these are like the y values. So a value of x should only have one arrow ever coming out of it. Okay, if it has more than one arrow coming out of it, that means one x value has multiple y values, and that is definitely not acceptable. Okay, so in this case, let's just double check. Each x value has only one unique value of y, right? The 8 has f, the 7 has b, the -3 has w, 6 has b. You see, these two have the same y value, but that's fine. That's like this one of these situations. Okay. So this one is fine. So far I got 1, that's okay, and I got 2, that's okay. This one, when x is 3, y is 2. When x is 3, y is 3. When x is 3, y is -4. Now this is totally flagrant, out of bounds. The same x value is having different y values. 2, 3, -4. This is not acceptable, so therefore this one is rejected. Okay? For D, I don't know if you have sharp eyes, if you noticed, but it is a copy paste of B. So I believe they've made a mistake here, which happens. It's a copy paste situation. I think what they were trying to do is maybe something like this. I'll try here. For example, if you saw something like this, then this would be not a function. Why? Because I have one value of x that is related to two values of y, right? You would have for coordinates 8 and w, and you would have 8 and f, and that's not acceptable. So if that were the case, this would not be good. So that's it for this video. Next one we'll cover questions 16 to 20. So make sure you subscribe to the channel so you can get notified when that drops. And as usual, like the video, give me feedback, comments, suggestions, questions. I'd love to hear from you guys, and we'll see you in the next one. Take care.